Welcome to the second part of our sine, cosine, and tangent ratios video. Now, we're going to have to do a little bit of extra work to find our sine, cosine, and tangent ratios. But first, let's review. Remember that sine is abbreviated sin and is the opposite over the hypotenuse. Cosine is the same as COS, and it is the adjacent side over the hypotenuse. And then we have the tangent. The tangent is the same as TAN, and it is the adjacent over, the opposite over the adjacent. And we have this acronym that's very popular that you'll hear people say, SOHCAHTOA. Again, it's there to help you kind of remember the order that things go in. If you spell it wrong, it's really not that helpful. So I want to find the cosine of angle A in this triangle. And my triangle is here, and it's A, B, C, and this side's 7, and this side is 24. Now, again, take it piece by piece. The cosine tells you that you are looking for the adjacent and the hypotenuse, and angle A is telling you what angle to look at. So I'm looking at angle A. The adjacent side to angle A would be 7, and the hypotenuse would be over here, but I don't actually know the hypotenuse, so I have to do a little bit of work. I have to do the Pythagorean theorem. 7 squared plus 24 squared equals c squared. 7 squared plus 24 squared is 625 after you do the math. And then square root, which gives you 25. So this hypotenuse is 25. So the cosine of A, the ratio of the adjacent side and the hypotenuse, would be 7 over the side I just found, which would be 25. Let's do another one. How about this time we find the tangent of side A, and here's our triangle. A, B, C, and here the hypotenuse is 3, and this side here is 2. So again, piece by piece, the tangent tells you that you're dealing with the opposite over the adjacent, and then A tells you you're looking at angle A. So looking at angle A, the opposite side is 2, and the adjacent side we don't actually know. So before we can do anything, we have to do the Pythagorean theorem. So this is 4 plus x squared equals 9. X squared would have to equal 5, which means x equals root 5. So now I can do my opposite over my adjacent. The tangent of A has to equal 2 over root 5. And again, I'm a good math student. I'm going to reduce my radical. So I'm going to multiply the numerator and denominator by root 5. This is 2 root 5 over square root of 25, which is just 5 in the denominator. And that would be my ratio. Let's do one more like this, and then we'll jump to our next example. How about the sine of angle Q? And we'll do a right triangle like this. And we'll say that this side is 2 And the other side is six. And here's my right angle, and we'll call this triangle QRS. So again, sine. If you think about your SOHCAHTOA, you need your opposite and your hypotenuse. So you need, and you're looking at angle Q. So here's angle Q. The opposite side of Q is 6, and the hypotenuse we don't know. So we have to do Pythagorean theorem. 2 squared plus 6 squared equals c squared. So 2 squared is 4, 6 squared is 36, so this is 40. So c equals the square root of 40. And again, you are going to be a good math student and you're going to reduce your radical. This is root 4 times 10, which is 2 root 10. So the sine of Q is the opposite. The opposite, which is 6, over the hypotenuse, which is 2 root 10. This is a time when you need to reduce your fraction and rationalize your denominator. Notice you have 6 over 2. 6 over 2 is 1/3. So you have 1 over 3 root 10. Then you will multiply your numerator and denominator by root 10. So you have root 10 in the numerator, and then 3 times root 100 in the denominator. Root 100 is 10, so this is root 10 over 30 for your answer. The other thing I'm going to expect you to be able to do is evaluate things like this. Like if I just were to say the sine of 30 degrees, this time you have an angle measure. Now, it's kind of hard without a picture, but whenever you see the sine of 30, think about the fact that this has to come from a 30, 60, 90 triangle. So just draw your 30, 60, 90 triangle. 30, 60, 90. Remember, your opposite side is 1. Your long side is root 3, and your hypotenuse is 2. So if you want to know the sine of 30, you're looking at the angle that measures 30 degrees, and you want the opposite over the hypotenuse. So the opposite side is 2, or is 1. The hypotenuse is 2. So the sine of 30 is 1/2. Let's go again. How about the sine of 60? Same triangle, but I'll go ahead and draw it again. This time I think I'll draw it, I'll just draw it the same way. So it's still a 30, 60, 90 triangle. 30, 60, short side is 1, the long side is root 3, and the hypotenuse is 2. So this time, the sine of 60, looking at angle 60, still doing opposite over hypotenuse. Opposite side of 60 is root 3, and the hypotenuse is 2. So it's just root 3 over 2. What if I asked you for the tangent of 45? Well, this isn't a 30, 60, 90 triangle. This would be a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, the sides go 1, 1, and root 2. In a 45, 45, 90, it really doesn't matter what side you look at. Okay? The tangent of 45 is the opposite over the adjacent, opposite over adjacent, which would be 1 over 1, and 1 over 1 is just 1. Feel free to rewind and go back. Let me know if you have any questions, and as always, make good choices.